we're just going to do one more example about force. The other one I had written down is one of your homework problems, so I'm not gonna give the punchline away there. So let's say from horizontal we've got two forces. I'm going to draw them on here first. They're working against, I'm going to be down here. This one's really long, this one's a little bit shorter. But we have two forces. This one has a magnitude of 2,000 newtons. That's capital N. And it is making an angle of 30 degrees with horizontal. Okay, this other force over here is 900 newtons. And it's making an angle of negative 45 degrees with horizontal. Okay. I want to come up with the magnitude and just the magnitude and the direction of the resultant of these forces. Okay. So again, pretend these are drawn to scale. They're really not, but I'm going to kind of give you a visual over here. So there's one force that's that long going that way, and here is the other force that is going that direction. And so the resultant would be if we put one of them head to tail and we drew, and again, definitely not to scale because this almost looks like it's going downhill, and I'm going to tell you the answer is not going downhill. That's where it wants to be. So that's the resultant force. I want to know how what its magnitude is, which means how many newtons, how hard is it pushing or pulling on that, don't think that color, on that object, and in what direction is it pushing or pulling. So again, my picture's not drawn to scale. It's not going to look like that in the end, but this is a visual of what we're trying to do. Okay. When we're trying to find a resultant force, let's call this one U, and this one, which this is the magnitude, not the direction, and this vector be V here. Okay. And so what we're trying to come up with at our desks is U plus V. Okay. Now, if I want to find vector U, we said, well, we can break that into component form by taking its magnitude times the cosine of the angle it makes with horizontal. It's 30 degrees. We know the y direction there is going to be the magnitude times the sine of the angle it makes with horizontal. And if we take 2,000 times the cosine of 30, we're going to get 2,000 times square root of 3 over 2, so 1,000 times the square root of 3. And 2,000 times the sine of 30 is 2,000 times 1/2. If we're looking at angle V, we know the x component is the magnitude times the cosine of the angle it makes with horizontal. And the y component is the magnitude times the sine of the angle it makes with horizontal. Oh, I'm off the edge. Okay. Now the cosine of negative 45 degrees, if I am in the fourth quadrant here, my adjacent side is positive along with my hypotenuse, so I know that the cosine is positive. Okay, and it's positive square root of 2 over 2. So I have 450 square root of 2. Now the sine of 45 degrees is also square root of 2 over 2, but because I'm in the fourth quadrant, I'm going to get a negative number there. When you're breaking your vector into component form, you should always take a minute to make sure you have your signs correct. Okay, notice that this vector goes to the right, which is positive, and then down, which is negative. So the x should be a plus and the y should be a minus, and that's what I have over here. When I'm going up and to the right, both components should be positive. If I want to find u plus v, then I'm going to add the x components together, and I'm going to add the y components together. I did that on my calculator before I started. So if you take 1,000 square root of 3 plus 450 times the square root of 2, then you end up with 2,368 point, I'm just going to round, 446911, so I'll say 0.4. If you add 1,000 to negative 450 square root of 2, you get 363 0.6 when you round. Okay, so again, as I mentioned earlier, this vector really should probably be longer and up more, and this one may be a little bit shorter, relatively speaking, because I need to twist him. Okay, we're actually going up. We're going to the right a whole lot and up just a little bit for that vector. Now, if I'm going to call this vector R for resultant. Okay, maybe I should call it F for force, but too late now. If I want to know its magnitude, then I'm going to take the square root of this 2,368.4 squared plus the 363.6 squared, and in the end I'm going to take the square root. I don't have room to write all that, so those are the numbers that go in there. That resultant vector has magnitude of 2,396.2. Okay, it looks like newtons is my unit. This guy was newtons, this guy was newtons, so the resultant vector will be in newtons. Okay, the total force exerted by these two forces of whatever they happen to be, is 2,400, almost 2,400 newtons. Okay. Now the angle, if I take the tangent of theta, it's the y component over the x component. And then I'm going to take the arctan of that. And because this is a positive ratio, I know I have a positive angle. I'm in the first quadrant, it's going up. And I should get that that angle is 8.7 degrees. So if I take a 2,000 Newton force going at a 30-degree angle from horizontal, pulling on whatever that object happens to be, and I have a 900 Newton force going at negative 45 degrees, then in the long run, my battery's going to die, so good thing I'm about done. The resultant vector goes in this direction right here, or sorry, has that magnitude. It does go in that direction, which is an 8.7 degree angle, and has that total force. And I'm going to hang up and find my cord before my recording dies without me. See you later. See you later.